Howdy, folks. Hopefully everybody had a good lunch. When you guys get a chance to come back over to the registration area, we have the lockpicking booth set up if you guys had a chance to play with that. We also have the Gringo Warrior Challenge where you actually have to break your way out of a jail cell. Pretty cool stuff. And right now, I'd like to introduce Adam Shostack, who's somebody I actually work with. He's going to be talking about the Security Development Lifecycle. It's something we use heavily at work, and it's exportable to other companies as well, and it basically covers how products and services get developed with security in mind from beginning to end. In Adam's case, he actually was the new version of the book. Because I was about to say, you wrote the book on it. Yeah. Not the original one, but... No, I have not written it. Oh, you haven't written it? Oh, okay. So he hasn't written the book on it, but he's damn smart. So... Go ahead and let Adam go ahead and start talking, and I think you guys will get a kick out of this one. It's pretty well researched. So,
Thank you. Thank you. Okay, now we have microphone. There's nothing better than coming after someone who's given an hour-long talk on how to present. So if you get bored, just focus on all of my flaws, and you can pay attention that way. But what I want to talk about today is I'd like to talk about threat modeling as we do it at Microsoft, and some of the lessons that we've learned. I've been at Microsoft for only 2 years, but we've been threat modeling, and I'll give you the history. But there's a tremendous amount that we've learned about what makes the process work and what doesn't work. And so the way I'm going to structure this talk is I'm going to give you a little bit of context. What's the SDL? What do I mean when I say threat modeling? Talk about some of the pain that we've experienced. Talk about some of the issues that we've seen as we've done threat modeling, as we've taken it out to 30,000 engineers. Talk to you about how we do it today, and then talk about how we decided what it was we were going to do today so that you can learn and you can adapt it to your own organizations. If you work for a company that develops software in some way, then you can use this. If you're a consultant, you can apply it at your consulting customers. And I want to give you the intellectual toolbox that I used as I redeveloped the process so that we're having more and more success as we actually deploy it. So some context. As Noid said, the Security Development Lifecycle is a mandatory process at Microsoft. All teams have to do it, whether they're shipping box software, whether they're deploying web services. And it's a comprehensive process. It goes from the conception of the software, where you're doing requirements analysis, through design, development, testing, deployment, and update. The MSRC, the Microsoft Security Response Center, the processes they engage in are seen as part of the SDL, and they include this learning cycle. We look at the patches that we issue and the updates that we issue and say, what can we learn? How can we drive that back in so we're less and less likely to make similar mistakes in the future? And threat modeling, which is what I'm going to talk about, is one of the primary activities we do during the design phase. Now, threat modeling as a term means a lot of things to different people, and it means a lot of things at different organizations. It's perfectly legitimate for someone to ask, what's your threat model? And I think of that as very IETF-centric threat modeling down in the bottom right-hand corner, your bottom left-hand corner of the diagram, where you've got experts thinking about the requirements that they're going to build to. And a good answer to what's your threat model might be a heckler in the audience or someone who takes possession of a laptop that was left unlocked over there during the break. Or it might be, if you're working with, say, the Tor project, it might be the global passive adversary listening to all packets transmitted anywhere. And this is a very expert-centric process. At Microsoft, we go from experts to all engineers. We ask everyone to get involved in the threat models, and I'll talk later about why. And a threat model analysis document is a longer, more complex thing. Some of these run to dozens and hundreds of pages, talking about here are the things that might go wrong in deployment. And so Most of what I'm going to talk about today is over on your right-hand side. It's the Security Development Lifecycle threat modeling process, which is designed to work for all engineers and has gone through a lot of refinement to make it work in that environment. So to allow you to understand where it is that we are today and where we're going, I want to talk in a fair amount of detail about the past, about what's happened and about what's gone wrong, because without knowing that context of what's gone wrong, it's very hard to understand why we've made the choices that we've made. And it's very hard if you go out and start to deploy a threat modeling process and you watch it break. Maybe I'll have talked about one of the ways in which it might break, and you can use that to understand how you can fix it. And that's why I'm going to go through the past in some detail. This is a Dilbert cartoon involving Mordac, Preventer of Information Services. And Mordac starts out by saying, security is more important than usability. In a perfect world, no one would be able to use anything. And then we've edited it slightly to complete the threat model, stare directly at the sun. And this is the way some versions of the process have felt to the people being asked to engage in them. So we've been doing this for almost 10 years as a formalized, documented process. We've been doing it for a lot longer. And when I say we, I really mean the company before I joined. There are people who have been doing threat modeling in various forms for upwards of 20 years, but finding formal documentation dedicated to what the threats are and how we're going to mitigate or address them goes back about 10 years. And in that 10 years, we've had just this explosion of interesting ideas which we've put to the test with a variety of real product teams shipping real software. And I mention that because when I've been a consultant, I've gone out and I've tried to convince people to do some threat modeling. And one of the questions which I run into very early in selling that activity is, this is just security geeking. No one real ever does this stuff, right? And so my answer to you, and the answer that you can take out and use, is that no, people really do this stuff, and you can make it part of a commercial development process. I'm cleverly taking a drink of water while you all read this slide. And my point in this slide is that we've been through an awful lot of versions of the process, and we've published an awful lot of those. Mike Howard and Dave LeBlanc's books, the threat modeling book, which Noid thought that I wrote, was Frank Swiderski and Wendell Snyder. And each of these versions of the process is different. And none of them match what I'm going to tell you today, and I'll tell you why that is. So the real big issues occurred when we tried to move from an informal process. And let me ask, how many people here have done something they would call threat modeling? Maybe a third of you? Did you have any documentation going in? Did you have any forms you needed to fill out? A couple of you have, and a lot of you haven't. And as we tried to write down what people were doing, we tried to write down a comprehensive view of everything they might do as they went through this process. And that resulted in this very complex process. It was 11 or so steps. And if you had, say, Michael or Window or Jason Garms or some of our other long-standing experts in the room, it worked really, really well. Some of the teams who have done this have great results. And we took it and we exported it and we said, it's really important that the engineers get involved, because when they get involved, they buy into the process and they buy into the results. If you have the expert show up and say, this is what goes wrong, then the engineer says, yeah, hang on, I'm working on this feature. But if you pull the engineer in and have them participate in the process of understanding what might go wrong, of participating in the threat modeling process, then when they actually go to write the code, they will remember those things. And so it's tremendously important to connect the process to development. The next issue we run into is a lot of people, when they threat model, start out by saying, first enumerate your assets, and then think about how an attacker can get to them. Well, when you ask everyone to threat model, you ask, say, the GDI team to threat model, GDI, Graphics Direct Interface. They're a graphics library. They don't own any assets. The ability to write to the screen is a privilege. It's a right. It's not an asset. And they threw up their hands and said, we'd love to do this, but we just don't know what to do. Connected to, or similar to disconnected from development, we asked people to write these threat models, and then we didn't really encourage them to do anything with them. And so if you apply the Yagni principle of you ain't going to need it, oftentimes threat models looked like something you ain't going to need and something you could just zip through. It was hard to tell if your models were complete. It was hard to tell if they were up to date or accurate. There were these very disconnected artifacts. And so there's this long list of pain points associated with the process. And one result of that is this profusion of attempts to fix it. We had an awful lot of people step out and say, okay, the process coming out of the central teams isn't working for me. I'll fix it. I'll do better. And we've had a tremendous number of those and a lot of really interesting innovation that lead up to the present day. And so what I'm going to do now is actually walk you through the process as we advise teams to do it within the company. And from there, I'm going to go and talk about some of the toolbox that we used to come up with this process and why it looks the way it is. But before I do, I want to say that it was explicitly built around fixing the problems that we were experiencing. We went from 11 steps to 4. One of the problems that we ran into, this jargon overload problem, was you would go into a room, you would start talking to people, and inside of 60 seconds you would use so many acronyms that they didn't understand and had no reference for, that they were convinced that you were from some other planet, and what's more, you didn't really want them to do this work. And the way that they knew that you didn't want them to do this work is because they got so disconnected from what you were saying that they tuned out. Product Studio is an internal bug tracking system that we use. It's getting phased out in favor of TFS over time. So we've integrated into the development process through bug tracking. We focus on the software, not the attacker. There's this advice that people love to give, and how many people have ever said you need to think like an attacker? Come on, you can put your hand up. It's okay. How many of you have ever said you need to think like a professional chef? For us, it's easy to think like attackers. We know what attackers do. We come to conferences like this. We see how attacks work. I'm willing to bet that there's less than 2 people in the room who have worked a professional kitchen and can actually plan a menu and get hundreds of orders out over the course of an evening. And when you say to someone who is a professional software developer but doesn't understand security, you need to think like an attacker, it's very much like coming to you and saying, think like a professional chef or think like an accountant. And so we've pulled away from that and we focus on the software and how the software is built. We encourage threat models as a collaboration tool. We encourage people to say, as part of discussions they have with other teams, can I see your threat model? And when other people ask for your threat model, what we found is that your pride of ownership, your pride of authorship increases. So we're trying to encourage the behavior we'd like to see by having it not come out of the central team, but having it come out of your peers. When we do that, we need to give people a way to understand whether or not what they've done is correct, whether or not what they've done is actually good. Because if you want to make it good and you don't know what good looks like, you're not going to get anywhere. And so we've put in a large number of self-checks in the process, both locally as you go through the process. Here's what you check as you're drawing a diagram. Here's what you check as you're enumerating threats. And at the end, there's an explicit validation stage, which is designed to give people the ability to go back and validate their own threat model. We look at threats as bugs. We look at mitigations as features. And there are some teams that look at mitigations that look at vulnerabilities as bugs. But the key here is that people know how to deal with bugs, and they know how to write features. And so when you go from talking about threats and vulnerabilities to bugs and features, you connect. Your audience gets it. They say, oh yeah, if this is just a bug, I can deal with this. I can triage it. I can assign it to someone. I can test it. And I can make sure it's not in the shipping product. I got it. Or if you have a mitigation, a way to prevent a threat, say encryption, that's a feature. People know how to write features. You can spec them, you can code them, you can test them, you can make sure they're documented. And so we're really trying to address the problems that people have experienced, both in the process and in the training that we deliver. One of the versions of the training that we delivered had this really great slide up at the front which showed the quality assessment of our threat models. And we'll just say it was poor, that the average threat model wasn't very good. And that was like the second slide of the training. Now, if I were to come here and say, I'm going to give you a bad talk about something and you're going to not understand it at the end, and when I ask you to do this, you're going to do a crappy job, I assume you'd all continue paying attention because you're here on a Saturday to learn about security stuff. But if you were doing anything else, if you're out there enjoying the sunlight, then perhaps your response would be a little different. So this is actually an abridged version, a very abridged version of the internal process training that we deliver. And it has 5 basic steps. It's start out with some vision and some requirements, build a model, identify threats, mitigate those threats, and validate what you've done. As you make changes, as you make architectural changes through the process, go back and make sure your model actually reflects reality. Now, if you look at this looks like just about every other 4-stage process you've ever engaged in, and that's very intentional. Familiarity makes it easier for people to wrap their head around what's new and hard here, rather than, oh my God, there's 11 boxes in a complex flow chart. So the vision thing involves encouraging people to push security into the things that they're already doing. Their scenarios, their use cases. Put your security in there. If you're using personas, we use a lot of persona-driven design. Ask yourself, what does this user expect would happen, and what does this user worry would happen? Think about where the product is going to be used and how it's going to be used, and what the security implications of this are. This is very informal. It's a little fuzzy, but after working with the SDL for 6-8 years now, there's a lot of knowledge there's a lot of intuitive knowledge, there's a lot of knowledge baked into teams. And so we find that people can actually do this and get pretty good results on a very informal basis, and that's tremendously useful because it allows them, even before they start to draw a design, to think about how they can enhance that design for security. The assurances process is something that we're working on. It's new, and it's a structured way to think about what you're telling customers about the product security. For example, what would we tell people about BitLocker security? What would we tell people about UAC security? And the core of the instruction is how can you make short positive statements of the form, only this user can do this or only this person can do that, because that makes it really easy to drive bugs. Oh, this user can do this thing. It's not covered in one of the assurance statements. We have a problem. That's something that I'll probably talk about again more in the future. So model. Start with a diagram. Start with a whiteboard level diagram. Everyone in software knows how to draw diagrams on the whiteboard. And threat model diagrams really aren't that different from your whiteboard level diagram. So I always start with an external interactor, someone outside who is driving the story that I'm about to tell. They're going to talk to some process. Some running code is going to do something with their instructions. Maybe it has some persistent data that it stores, and then you connect it all up. And that's a context diagram for a threat model. It's really easy. You can do that. You can check your work, right? You can tell a story using the diagram, and if you have to go back to the whiteboard, your diagram isn't complete. Fix it. But you get a whiteboard, so it's easy. And then you can break it out into more and more detail as you need to do that. So we encourage people to use these 5 diagram element types. External entities, anyone outside the system. Processes are all running code. Data stores and data flow, or data flows, data stores, and then trust boundaries. Some of you who have been paying a lot of attention to threat modeling may notice that we've eliminated this double circle thing that used to be there because no one could actually give clear advice on when to use what. It was a complex process. What makes a complex process in a threat model? I had an intuitive grasp, and I tried to write it down, and I couldn't, and I asked some of my colleagues, and they couldn't, and so it's just gone. So if you see it in other documents, that's why. So once you've drawn these diagrams, I said, add more detail when needed, and that's really fuzzy advice, too. That's the sort of advice that I hate. And so I had to get prescriptive about what you should do to break it out, and it's really that you need more detail to fully explain the security impact. The other place that it happens is an object would cross a trust boundary. And if you look to the formalisms of what a DFD with a trust boundary is, trust boundaries are only ever supposed to cross a data flow. And we used to yell at people who would draw their trust boundaries across databases, or they would draw their trust boundaries across a process. And we realized that what they were really doing was expressing something very important. They were expressing that there was this detail there, that they knew intuitively that the two sides of that boundary were different. And so rather than telling them, don't do that, we say, that's great, that's wonderful, do what you want to do, put the trust boundary there, and then break it out. You also found that people would say things like, well, sometimes this database, if you were modeling, say, an online bookstore, sometimes this database contains our inventory of books, and sometimes it contains our credit cards. Well, logically, that's 2 different databases. You might have one big SQL store that holds all of it, but from a logical perspective, from an ACL perspective, from an audit perspective, they're different things. So treat them differently. So the next step in the process, and I should point out, we've got this little doohickey to remind you where we are. Is identify threats, and most of the people here can identify threats looking at a diagram. If I had a whiteboard here and I drew something and I said, hey, let's attack it, and I have a prize for who gets the best attack, you guys would be all over it. You ask a bunch of engineers, how do we attack that? And they're like, buffer overflow, SSL, SQL injection. You didn't get good, clear responses. And so we have to give people clear guidance as to what we want. And the methodology that we're using today is what we call stride per element. And what this is if you're considering a data store, you worry about people tampering with it. You worry about the data in it being disclosed. You worry about denial of service. And then there's that red check there, which is repudiation. In writing big, repudiation doesn't really fit. And if your data store is a log, you have to worry about repudiation. If you have a data flow between 2 things, you worry about tampering, information disclosure, and denial of service. If you have an external entity, you worry about spoofing and repudiation. Now, I want to be really clear that this is the chart that we're using, and it's primarily driven by the sorts of things for which we would ship updates. There are interesting security problems which are in the blank space in this chart, which may matter deeply to your organization, to your customers. My favorite example is information disclosure by external entities. Information disclosure by external entities sounds a lot like a privacy breach. And if you're a fan of the attrition data loss database, you will know that there have been 1,000 or so of those in the press in the last few years. And this actually is one of the things that drove my question to the previous speaker about who's getting fired. Because when you analyze that stuff, it turns out that a lot of the things that we worry might happen after a breach don't actually happen. Stock prices don't fall. People don't get fired. And there's good information out there. But I digress a little bit. The key point is that this chart works for us. It may or may not work for you. It's probably a good starting point. It's probably not the ending point. And changing this chart around is going to be an expert activity. It's going to remain an expert activity. It's not the sort of thing because you expose someone who doesn't know how to think about security, they can't find any spoofing threats in anything, they'll chop it off of the chart, and your authentication and authorization processes will get all messed up. Was there a question in the back? I should say, if I'm not being clear, please feel free, ask questions. I'm happy to be interrupted or EOP, thank you. Great question. EOP all the way over here, elevation of privilege. Across the top, spoofing, tampering, repudiation. Yeah, okay. Yep, okay. Look, here we go. Elevation of privilege, right there. This is one of many slides that I use in giving the training and I don't want to spend time walking you through it, but the threats that we worry about are the opposites of the properties that we would like to have, and we define them and give examples of each of them that people can use and look at. So going from threat identification to mitigation, it doesn't actually do you any good, and it may harm you substantially to go through the process up to here and stop. Because what you've done is you've done an analysis of your design, or you've written out your design, you've analyzed that design, and so now you know about this set of problems and you stop. Someone's lawyers are going to love you for that. So you have to address each threat. And there are 4 primary ways that you can do that. You can redesign the thing you're working on. Put in a reference monitor, make sure that everything goes through the same authorization scheme, etc. You can apply standard mitigations. And by standard mitigations, what I mean are things like ACLs and cryptography and digital signatures, using prepared statements in your SQL system. You can also look to what similar software packages have done and how their various defenses have worked out for them. One of the very useful things about responsible disclosure or even full disclosure is that you can actually look to this set of attacks against things similar to what you are building and learn from it. This is often also an expert activity to sit down, analyze the attack, apply it to your own product, but it's tremendously powerful. You can invent a new mitigation. You're doing something new in software, then you might have to come up with a new way to address a problem, and that's tremendously risky for reasons that I think all of you have experienced. The final thing you might do is you can accept a vulnerability in your design. Inside of Microsoft, we have rules and policies about what you're able to accept, and it's great to set these up before you start the process so that you can make clear calls on these things. So, validation. You have to validate the whole threat model, and there are some steps you can do. Again, this is about making it prescriptive so that an engineer can do it without the expert handy. Does your diagram match your code? Did you enumerate your threats? Have testers looked at the threat model? I find that getting test involved in security is a win-win. Testers have some of that security mentality that Bruce Schneier talks about. They have some of that, I wonder what happens when I poke it, or I wonder what happens if I poke it again. Ooh, look, it falls apart. And they might not have the skills necessary to understand how to poke things in security-relevant ways, but they have a lot of the same approaches, and getting them involved often finds both issues with your threat model and issues with the details of the attacks. And then you want to ask yourself, as you validate your threat model, have I mitigated each threat? Did I do the mitigations correctly? And we have a lot of examples that I'm not going to go through here. How am I doing on time? I realize I forgot my one. I've been a half hour. Okay, excellent. Either I'm doing well or you're all really tired. I hope I'm doing well, but if you have questions, please, again. Oh, yeah, finally, it's important to threat model at the right time. Analyzing their attack pattern when the rebel ships are attacking the Death Star, it's a little late to make important design changes. They had to build another one. So try to do this early in the process rather than late. So going into the future, both in SDL and what we're doing in threat modeling, and here I want to talk about some of the possibilities as I hope you pick up on threat modeling and actually go do it. So there's a lot of different types of threat modeling. You can make your threat models asset-centric. You can make them attacker-centric. You can make them architecture-centric or software-centric. You can threat model network protocols. This is the core of that security consideration section in every RFC. There are lots of others. There's not a right way or a wrong way to do this. There are more and less effective ways for organizations to do this. And so what I want to help you do is think about threat modeling as a tool that you can use, a little bit about what tooling can look like, and how you can think about software for threat modeling. So how do we actually assess the various possibilities, right? I listed 4. I said there's a lot more. And I think there's a lot of important future in thinking better about security tools and in thinking about what the design trade-offs that we make are. And this is getting a little philosophical, so please just bear with me for a minute or two. And I'm going to talk about how and why to think about design and usability for programmers and a technique called flow, which I found to be incredibly helpful to me as a process designer. And I want to talk through these and then address for each of them, what does this have to do with threat modeling? So when you think about buying a car, most people have bought a car. There's an awful lot of things you can think about. You can think about how many people you need. You can think about comfort. You can think about the image that you want to project. Am I the sort of person who drives a Ferrari? Am I the sort of person who drives a Prius? People who buy Ferraris do, one reason might be because they want to project that image of wealth. And there's a tremendous market for all sorts of cars, some of which I look at that and say, why would anyone buy it? But the truth is, someone does because I just looked at it. So some car company spent the time and effort to build this car, market it, and then someone bought it, and now it's sitting in front of me blocking my view of the rest of the road. And that's okay. That's a good thing. And oftentimes, as we've talked about threat modeling, we'll talk about the one true way. We'll talk about this is the way we do it, and the implication is this is the way you should do it. That's totally wrong. Threat modeling as a set of ways to approach design or to approach the analysis of software should be a big tent because the requirements that you have are different. Just like buying a car, if you need to transport a family of 8, you need a very different car than if you're a single person. If you're deploying this at a large software company, you might have a very different methodology than if you're applying it at a consultancy, if you're applying it, say, at a medical device manufacturer. There's all sorts of processes which we will come up with over the next few years, each of which solves a problem that someone has. And it's important to understand what your problem is, why you're changing the process, because that's going to drive how you change the process. So one thing that I think is tremendously important for all of security, this is going way beyond threat modeling, is thinking about developers as human beings. There was a great paper by Todd Miller and Theo Durat on stir-L copy and stir-L-cat. Have people read this paper? Anyone? No one has read this paper. You should all read this paper. This is a great paper. In this paper, what they did was they audited the OpenBSD source for misuse of stir-N-copy and stir-N-cat. Note those are the N versions. Those are the versions where you don't just say, yeah, copy these two strings or copy this into that buffer. You actually have to provide a length value. And people messed it up. And in the course of writing the paper, what they did was they analyzed the ways in which people messed it up, and they said, there are some patterns that we see. People have a bad mental model of stir-N copy. And because they have this bad mental model, they make the same mistakes over and over again. And so what did they do? They didn't go out and say, we're going to change everyone's mental model. That's hard work. What they did was they designed a set of copy functions that conformed to the model that their users expected them to have. And that's a really clever approach to the problem. So usability isn't just about your mom. It's not about your grandmother. It's about programmers. It's about security people. I can't tell you how many cool security tools I've wanted to use, had 15 minutes to figure out whether or not I could use them, and gave up. Went on, found a different tool, which may or may not have been as fit for purpose as the first one I was looking at, but it was easier for me to understand. I was under a tight deadline, and I had to learn something new quickly. So usability is key for programmers, and you don't need to be an expert to make usable software. It's actually not that hard. It's hard to make software that has beautiful usability. It's hard to make software that has great usability. But it's easy to make software which has a baseline of usability. And the basic, simple way that you do it is you watch users and shut up. You sit down and you hand someone the software that you want them to use, and you say, do this thing which is a key purpose of the software. Let's say it's Nmap and you want to do a test. Scan a box over there on the network. And you just sit there and watch them and take notes. And the first couple of times that you do this, you cringe. You cry. It's awful. It is so painful because they're missing the obvious thing that's right down in the corner of the screen in very, very low contrast text, which is a key thing. Sort of like my copyright things down there in the very bottom left-hand side of the screen. It's low contrast because I don't want to draw your eye to it. But I've seen important switches for software that are that hard to find, that the command line isn't well documented, or that you need a string of 7 different command options to do this really common basic thing which everyone wants to do. And if you read the man page in the example section, it lists, to do this, here's the 7 things. Then you read other manual pages and they say, here's an option that gives you all of these common defaults that you're going to want. There are some techniques, and I'm not going to delve into these, but paper prototyping, the basic idea is you take Visio or Photoshop or even a whiteboard, and you just draw what you're planning to build. And you show it to people and say, if I wanted you to use this thing to do this, what would you do? What would you look for? And when you give them these paper prototypes, they're very willing to give you answers, and you haven't done any code writing. So it's easy. You don't have to redesign. You do your design up front with a paper prototype. You can ask people using your software to think aloud, to say, So I want to scan this machine. So the first thing I'm going to do is just try Nmap and the machine name and see what that delivers. And Nmap is cool. That will work. Or you might give them another task, which is give me a list of all of the open UDP ports on the machine. And the default UDP scan only goes 1 through 1024. So do they actually discover that, or do they just give you the open ports on machine, the open ports from 1 to 1024? Another great technique is personas. Write down, Abby is a mom who uses her computer for a few hours a week. Toby is her teenage son. He's into P2P file sharing, plays first-person shooters, and knows his mom's password. So you write these things down and then you can ask yourself, okay, how would Abby use Nmap? Or how would Toby use Nmap? And you can go through the mental exercise of saying, how would I actually engage with this? All three of these are very useful. All of them, there's a tremendous amount of depth in doing them to perfection. There's depth in doing them well. But taking a first step pays off tremendously on almost everything I've ever worked on. So I'd like to move to a concept from psychology called flow. And flow is this state where the person is fully immersed in what he or she is doing, and it's characterized by a feeling of energized, focused, full involvement, and success. And there's a set of these. There's elements that lead to flow. There's clear goals. There's concentration and focus. Actually, before I say this, the psychologist who came up with this idea did it because he discovered that when talking to people who were successful in a wide variety of fields, in rock climbing, in surgery, in chess, all of these people used remarkably similar words to describe what it was they were experiencing as they were engaged in these things in which they were highly skilled. And those elements involved goals, concentration, a loss of feeling of self-consciousness. Going back to our previous speaker, a number of questions were about mumbling. They were about what do you do if you're scared of the audience. This is that feeling of self-consciousness that if you are feeling self-conscious about what you are doing, it is hard to focus on what it is you're doing. If I'm standing here very worried about, are these people paying attention? Did I button my shirt? Do I have something hanging off my lip from lunch? I'm self-conscious. I'm not focusing on providing you with this information. There's this distorted self of time. I get up here. I don't necessarily have a good, solid idea of how long I've been talking. There's direct and immediate feedback. Asking people to raise their hand, asking questions as I'm speaking here, it helps me to know if I'm connecting with you or not. The next one is absolutely key. There's this balance between ability level and challenge. For most of you, if I ask you to cook dinner, I suspect that I'm not going to starve. Cooking one dinner and cooking 500 dinners, totally different levels of challenge. And most of you will be up to cooking dinner for a few people and not up to cooking dinner for a few hundred. So there's this balance between ability and challenge. There's a sense of control over the situation or activity. It's rewarding in some way, and people become absorbed. And so you may be asking yourself, what the hell is this guy talking about? How does any of this relate to threat modeling? And the answer is, as I did interviews and as I talked to people about their threat modeling experience, I happened to be reading Csikszentmihalyi's book, Flow, The Psychology of Optimal Experience, and it just kept slapping me in the face what a good description of threat modeling, or how little a description of threat modeling had to do with a flow experience and how much it had to do with a failure to engage on an awful lot of these points. And so there's this diagram which he has, and over on the left side is challenges, high to low, and on the bottom is skills, low to high. And the idea is that as you learn, you start out at point A, where you have no skill and very little challenge. And actually, I saw a woman who designs games for the Xbox talk about this. That intro level that all games have is point A. Point A in a first-person shooter is about giving you a low-challenge, low-skill set of things so you can learn enough to actually go out and engage the monster. And then a well-designed game delivers to you new items, new vehicles, new skills, or new skills for your character within the game. And so as you play, it unlocks more and more of this. And what happens is, you go pick up the grenade launcher and you go from A to B. You're a little anxious. You don't know how to fire the grenade launcher. You don't know how big the grenade launcher's impact will be. And then you play with it a little bit and you move to point D. You go back into this flow channel because you've learned how to do this. Now, if the game doesn't actually add any challenges as you're playing, then you get bored, and probably from point C you go to point somewhere else where you put the game down and do different things. So going into threat modeling, what we've tried to do is to provide people with this set of instructions for going from, say, point A. They need to draw a DFD. They need to draw a data flow diagram. And we've told them, you want to do that like a whiteboard diagram. Oh, I've got some rules of thumb. I know that I'm doing the right thing. I've learned that. I go on to my next challenge, which used to be I need to brainstorm. Now it's use stride per element as a way to know how to get through this stage of I need to actually enumerate threats. And so there's a very conscious approach that we've used and that we've had success with of break it down into small pieces. For each of those small pieces, give people a challenge and then a way to validate that they're actually doing the right thing so that they don't spend too long in that anxiety zone and that they can actually go through the whole process and get to a result and feel good about it. So what is the future going to hold in threat modeling? I think there's going to be a tremendously diverse set of threat modeling processes out there. There's processes and tools which work for the problem at hand, not just the problem that we have at Microsoft and that I've been working on solving. I think there are problems where each of you might be able to use threat modeling techniques to do design analysis in the work that you do, and that if you come and select one of these systems that will work for whatever project it is, and whether that's asset-driven, attacker-driven, software-driven, if your development process is very waterfall or very agile, if you have a bunch of experts or if you want to involve everyone, or whatever sort of process you're looking at, you can actually apply this, and you can modify it to work for the problems which you're experiencing. So I've tried to give you guidance here, both on the very philosophical end and on the very practical end, because I believe both are important. How you can actually engage in the process the way that Microsoft does it, and a lot of the philosophy that lies behind that so that you can actually modify it to work for you. And so I'd like to have a little call for action here. I'd like you to go and actually threat model things. And I'd like you to enjoy yourself as you do. It's a fun process. If you threat model nothing else, threat model the security line at the airport on your way home. Ask yourself, how would I attack this? And then take it a step further. Right? Once you've got a couple of attacks, how would I help someone who's not a security expert do this thing? How would I give them a set of questions or a set of mental techniques to do what I just did? So enjoy yourself as you do this. Choose a system that works for you and make sure that you do it at the right time. I've been blogging a lot about this on the Security Development Lifecycle blog at blogs.msdn.com/SDL. And so with that, I think we've got a fair amount of time for questions. So, questions? Yes?
So the Microsoft SDL process is very expansive, it's very broad. What do you think are the most critical elements from it if you want to deploy some sort of SDL in a fairly large organization and the environment's going to be quite hostile to it?
So the question is, the Microsoft SDL is expansive, and where do you start if the organization is going to be resistant to it? Let me answer that in two parts. The first technical and the second organizational. On a technical level, I would start with, I'm going to flip that around actually, and I'm going to answer on the organizational level and then the technical level because it influences it. On the organizational level, I think you need two things. You need some success story, which you can use to convince people that this is a worthwhile investment of resources. And that's going to be dependent on your organization. We can talk about that a little bit offline if you'd like. But at Microsoft, there were a series of events that led to a strong level of executive support. And the executive support dovetailed with work that people like Mike Howard and Jason Garms had been doing to actually develop these processes at a grassroots level. And so when the executive said we need to do something, there was actually something there to do. And so whether you'll get the question of what do you start with, I think you should start with threat modeling. I think everyone should start with threat modeling. You can get results fairly quickly with a whiteboard diagram and stride per element in finding problems. That doesn't necessarily give you impetus to fix them. Another technique that might work for getting started would be fuzzing. We all like to laugh at fuzzers, but the truth is fuzzers find things which are clearly bugs. And if you fuzz something and it falls down and you fuzz it more and it falls down more, that may be a very actionable thing for someone. You can demo, okay, with 10 hours of fuzzing work, I found these 4 bugs. Let's go get them fixed. And then you can say, well, we've gone through that process. We fixed those bugs. Then we fuzzed it some more and we found some more bugs. Maybe we need to start thinking about this. What should developers do differently during development so that we don't have as many bugs that fuzzing can find? How do we take that lesson of fuzzing and expand it to our whole testing organization? Right? And this is where it's very dependent on your org to be able to say, where will you get traction and where will you be able to find successes, so that at some point when you want to say, we should devote N% of our development activities to security, and someone says, well, what will we get out of it? You have an answer that isn't just this is what Microsoft gets, but it's what you would get. Does that answer your question?
Yeah.
Okay, great. Other questions? Yes? So the question is, what sort of proof points and audit points do we have for audit and SOX 404? So we actually have, so the Security Development Lifecycle is really 3 things. It's education, it's tools, and it's process management. And within the tooling, we have a tool that everyone who's involved in the SDL registers their project and does things like, for example, they will upload their threat modeling files where we have automatic analysis techniques to make sure they meet a minimum baseline. We have them upload the results of all sorts of tools. We have people whose job it is to work with the teams who are actually doing these things and document and report on what's being done. So there's the automated tools, and then there's the human beings, and some of them intersect. For example, one of the design stage requirements is that you provide us with a query that works against Product Studio to report all of your security bugs. So later on, a security analyst can go run that query, look at all your security bugs, look at the ones that haven't been closed yet, and get some, or look at the ones that are marked won't fix, and say, why was this marked won't fix? Oh, because it's an admin attack. It's an attack that only admin can execute on. Well, if only admin can execute on it, maybe it's not an interesting attack. We found it. We triaged it correctly, or maybe there's an attack that was triaged incorrectly, but there are people in place who do that.
Okay, so you rely on internal tools to provide this attestation.
Mm-hmm.
How do you stop people from, and I guess just automated tools stop people from going ahead and...
How do we stop people from cheating?
Yeah, but suggest something that we could use in a smaller organization, because I run into that a lot. You know, if there's going to be an audit, I want to be able to prove we're doing this, taking for compliance.
Mm-hmm.
Or reporting. And it's really difficult for me to go to PwC people and say, look, we're doing it.
Right. So how does a smaller organization do this? And I think, again, it's going to be somewhat organization dependent, but I think that things like training, tracking who goes through what training, right? Has everyone been, we have a lot of online training. When you go to the online training, or if you come to Blue Hat, you get training credit for that, and it's easy for a manager to see what the status of their group is with regard to training. So I think that's one thing that's pretty easy to duplicate. Another is look for your bugs, right? If you find a security bug, the policy is you file it like this with these fields. How in-depth you need to be is going to be very industry dependent. I don't want to say anything about HIPAA or SOX or... I think we might agree on that opinion of SOX, but it's going to be dependent on what evidence do your auditors expect? What can you give them that will satisfy them? And I would be very upfront about saying, look, we need to do this. We need to do this on this budget. Auditors will always, always, always ask for more because it's covering themselves. And so you have to say, what is the value of this thing you're asking me to do? How much does it cost to do that? Do we get that value back in assurance? Okay. Yes?
How do you guys ensure that the knowledge that most developers now have to deal with security and whatever education you give them doesn't lead to pseudo-security solutions?
How do we? Could you expand on the question a little bit?
Like if your average application developer who may or may not know so much about security hears a lot about something related to their domain like key security, and they try to implement some solution that isn't really the overall term of security. How do you ensure that?
How do we ensure that developers who may not have as much knowledge as they should get it right? There's two answers. The first is a lot of the training tries to sensitize people to where the areas where they might make mistakes are. So, for example, there's a slide that I have in here about how to mitigate the problems. And in there, what it says is, right, invent new mitigations, this is riskier. There's a whole other set of slides about why it's risky and how to deal with it. There's a whole set of people. Larger teams have security teams. There's an Office, TWC, Trustworthy Computing team. There's multiple security teams within Windows, within Exchange, within SQL. There are experts around who will help. And so there's a tremendous amount of resources that we make available to people so that, one, they can realize they're on dangerous territory, and two, they can get help when they're there. Okay? Anything? Yes?
Does Microsoft consider their threat models to be public or auditable, or do they have a separate set of threat models that they give to their auditors?
Do we consider our threat models to be public or auditable? They are not public. They are definitely auditable and audited. We work with both internal teams who will do those audits and external vendors. At the end of the Windows Vista process, we thanked a number of vendors, and I don't have the complete list off the top of my head, but it included companies like Motasano and IOActive, who came in, and some of those folks actually read through the threat models. They went and engaged with the teams. They asked questions about them. So we have both internal and external audit of what's in the threat models. Anything else? All right. Well, thank you very much.